Hi, I am Manuela Buonanno and I work at the Radiological Research Accelerator Facility. Objective of this activity is to learn how to make microbial cell culture dishes for microbeam irradiation of cells in vitro. For this activity, we use specially modified 60 mm Petri dishes. The bottom surface of a Petri dish is too thick for the incoming particle beam to actually traverse it. Since microbeam irradiation at RARAF occurs from the bottom, charged particles have to hit and traverse the bottom surface of a cell culture dish before reaching the target cells. Therefore, Petri dishes are modified in order to ensure that the incoming particle beam will reach and actually traverse the target cells. Now I'm going to describe how to make cell culture dishes for microbeam irradiation. The elements required for this activity are just out-of-the-shelf laboratory material. 60 and 100 mm Petri dishes, a 600 grit sandpaper, 2-component epoxy glue, a 3-micron polypropylene film with one side that is electron gun treated in order to enhance glue attachment, a BD cell tack that is a specially formulated adhesive protein solution, 18 to 22 mm D cover slips, a roller, and plenty of ethanol 70%. In order to allow the particle beam to traverse a Petri dish, a 0.25-inch diameter hole is drilled into its center. However, the cells need a surface to grow onto. For this purpose, the hole is covered by polypropylene that is glued to the outer surface of the bottom of the dish. In this way, when viewed from the top, the hole and the polypropylene film form a well in which the cells can grow. So have ready the 60 mm Petri dish with the hole, sandpaper, the epoxy glue and a roller, and the polypropylene film. Now, for better glue attachment, the outside surface of the dish is gently scratched with sandpaper, and we usually make a cross, just like this. With the roller, a thin layer of glue is spread, and that is followed by the polypropylene film. Following polypropylene attachment, the dishes are baked at 90 Celsius degrees for 2 hours. Once out from the oven, the dishes are ready to be sterilized by soaking them in 70% ethanol for 30 minutes. Make sure that the dishes are completely immersed in ethanol. So after 30 minutes, have ready in the hood 100 mm Petri dishes. So that each 60 mm dish can be placed inside a 100 mm dish. In the hood until dry.
Once dried, the dishes are ready for cell plating. However, most mammalian cells plate poorly on polypropylene. So, to enhance cell attachment, the film is coated with BD cell tack that is a specially formulated adhesive protein solution. Have ready a working solution made of 100 microgram per milliliter cell tack plus 0.2 molar sodium bicarbonate. Add 20 microliter of the working solution to each well. And please make sure that the entire polypropylene surface is covered. Then, incubate the dishes at about 37 degrees Celsius for 30 minutes. After 30 minutes, it's time to rinse the cell tack off the dishes. Rinse the dishes with 5 ml of sterile distilled water. Gently remove the water from the well without damaging it. Repeat this step for 5 times. Now, once dried, the dishes are ready to use, or they can be stored in the refrigerator for no longer than 2 weeks.
To easily locate and image the cells at the RARAF microbeam, 200 to 400 cells in a volume of 2 microliter must be plated in the center of the polypropylene film. So, cover the droplet with a sterilized cover slip. Incubate the dishes until cell attachment, that depending on the cells, this might take about 5 to 30 minutes. After, add 5 milliliter of medium to the dish, remove the cover slip, and the cells are ready to be irradiated 24 hours later.